NU-KESS aims to provide evidence-led policymaking by enabling researchers to present their findings to local decision makers. The concept was developed by Professor Sally Shortall and her colleagues at Queen's University Belfast. Here in the North East, we have a partnership made up of 5 local authorities, the North East LEP and the Chamber of Commerce, alongside the North of Tyne Combined Authority. Today's programme will look as follows, and I'm going to hand over to, no it won't, that's not the right programme, but I'm going to hand over to Mark now, who is going to introduce the presentations from Savas.
Come back 2 seconds. Can you hear me? Yes. Yeah, so I'm Mark Stamper. I work at the North of Tyne Combined Authority. Thank you everyone for coming along. Savas is going to give us a presentation now, which myself and my colleague Martin will respond to once he's covered that.
Good afternoon, everyone. Hi, my name is Savas Ovegenidis. I'm Professor of Innovation and Enterprise at Newcastle University Business School. First of all, many thanks to Holly-Ann for coordinating this session, and of course for Mark and Martin for having a number of discussions leading to the presentation itself, and seeing what is hopefully of interest to the practice community, the Northeast and beyond. Today I'll be talking about a project. Let me share my screen so that we have something to refer to. That we've been working for a number of years around economic clustering and methodologies with which we can map them and get a sense of what is happening at the regional level. So I'll talk about 25-30 minutes just to give you the background and the rationale for the study, and then we can discuss potential ways forward. So when I go through the presentation, please keep in mind that what I'm putting forward is a tool. And what we are interested in is potential applications of that tool. The project, as I mentioned, started about 5 years ago when I had a chat with a colleague who was supervising a PhD student. And that student had a probably not very exciting task of going to a number of websites, downloading information from the websites, and then trying to figure out what those companies of which the websites belong to were doing. He was more specifically trying to map the Northeast subsea engineering section and was trying to do that over time. Now, as you can imagine, it's a very laborious task and it's not very exciting task. So he basically said, well, is there a better way of doing this? To some degree, naively, I answer there must be, and I set on a course to answer that question and come up with a better methodology. This is a longitudinal effort in the sense that it has lasted for about 5 years now, and in the process of that, we have applied the methodology through funding we got from the AHRC, but also from the Office of National Statistics to various cases and applications in the Northeast, but also at a national level. So the background of why we're doing this is because industrial clustering can inform policy in a number of ways. Understanding what is happening at the regional or national level, or even international level, can help policymakers in making hopefully better informed decisions. You can also look back perhaps in time and also see how the decisions you already made had an impact, positive or negative, to the clusters. And whether, for instance, adding some funding to the pot has made a difference to a growth of a particular cluster. There are a number of methodologies with which we can identify clusters. For instance, at the academic side, we often talk to managers. I have a social network analysis graph on the slide where we can go to each of the companies, ask them with whom they are working on, trying to map those kind of micro relationships upon clusters. And there are famous studies of this nature. For example, in Silicon Valley, trying to look at how the various technologies are developed over time by these kind of interactions among the companies, and see how the information flows and resources flow and relationship build. Of course, that is a very laborious exercise, and it's very difficult to scale up. On the practice side, the government uses what is called the Standard Industrial Classification System, or SIC codes for short. It is a system that has been around for almost 100 years now. It was introduced in the United States in 1937. And we have used variations of this SIC code system in the UK since 1958. Effectively, it's a very long list of codes with which we try to capture what is a particular company doing through the annual company return. So there is a box that they have to fill. The list itself has seen a number of developments. It has been updated to include additional codes to better represent potential industrial activities. With the latest version of it been published in 2007. Effectively, as I say, is a very long list. You can see an example here where we have the division section A, agriculture, forestry, and fishing. And under that, we have groups and classes of subclasses that more specifically describe the activity that the company is involved with. So, for instance, we can have 1.01.1.12, which is the growing of rice. If you have vegetables and melons, roots, and tubers, you have to pick 0.13. It can go down to that kind of detail. And as you can imagine, this results in a really long book of some 700 pages of codes after codes after codes. For most companies, of course, one or maybe two or even three classification codes will suffice to capture the essence of what the company is doing. But even on the SME scale, sometimes you do find that this type of, picking of codes isn't enough to more holistically describe what the company does. If you are working in a medium or large or organization with a number of products and services, having this kind of limitations, of course, is not very conducive because, even half a dozen codes will not suffice to capture everything that the company does. And then, of course, we have two other significant limitations. The first one is that the last time the classification was updated was in 2007, and there are a number of things that are not there. A lot of things, for instance, have happened, as you will see later on, in the digital sector. And also that in order to address the issue of code not existing to describe activities, there exists a catch-all other type of code that basically is used when there is no SIC code for a particular activity. So sometimes companies find it very convenient to just pick the other category and just move on in the rest of the return. So the initial research objective was, can we look at ways that we can potentially duplicate what that PhD student was working on, hopefully in a more systematic, hopefully in a bigger scale, but hopefully in a more automatic way, so that humans do not sit in front of PCs trying to download manual information, because otherwise you cannot really scale up the activity. The implicit question that we had set was whether we can find an alternative for the SIC code system. I have actually over the years moved away from asking for an alternative of the SIC code system. I'm now thinking more in lines of finding complementary to the SIC code system, because as you will see, there are a number of limitations in the approach. So it's useful to recognize what the strengths of the methodology are, but also as how far it can go, especially when you have very specific research questions or practical questions that you want to study. It's very helpful to know how far your methodology will take you so that you can appreciate the potential implications that can have for interpreting the findings. An example may be, as I mentioned earlier, that the SIC code has been updated in 2007, and we found ourselves trying to understand what a sector like the digital sector is doing when a lot of the activities and a lot of the technologies that are currently available were not available back in 2007. And of course, the list was published in 2007, but some preparatory work happened earlier. So probably it doesn't even reflect what was happening in 2007. Give you a list of technologies that may not be captured there, sharing economy activities, smart homes, even social media as we know today. It was just an infancy and may not be represented in the SIC code system. So a company like Facebook may just pick marketing or maybe ID development, but not social media because the code doesn't exist. So if we want to look at how classes in the digital sector or subclusters within the digital sector are created and dissolved potentially over time, it will be useful to somehow go out there in the wild and collect the data and more specifically look at what is happening, and then depending on the research question we've set, come up with the interpretation and any action that is necessary. So today's workshop event is around very much on this, thinking about the broader picture, if you like. What sort of policy questions and applications can we think of? How can we then apply the methodology so that we can end up with the right interpretation, appropriate interpretation, and hopefully some action that will follow on that. So while spending most of my presentation is looking at that middle part, try to give you some insights as to what can potentially work and how it works, so that you can think about the red boxes, what kind of questions we can potentially set, and how we're going to interpret and interact with the data so that we can come up with the right actions. We've started by doing this cross-sectionally a few years ago. We look at the Northeast for a number of reasons. Because we know, have a good idea as to why it's happening in the Northeast in terms of the sectors that we have, but also because it was one of the smallest regions, and it was a useful thing for the methodology to go through trial and error steps with something that was feasible to iterate, and not go with, say, London, which was a much bigger exercise. We came up with a number of clusters, as I have on the slide. So for instance, the very first one was computer data processing service. The labels are labels that we have come up with. There are ways you can generate these labels, but basically we just look at the top terms that represented the clusters that we were mapping through website data. For instance, we had domain, software, hosting, web, storage, computers, control, air, probably operational, and server. So all these are terms that you probably associate with computer and data processing service, and that's where the label came from. So we had a number of these. I haven't got all of them on the slide, just to give you a flavor, a number of these clusters, and we had some associated terms with them, the top 10 associated terms. And as you can see on the left, there was a number of the companies that fell within that particular sector. So in this case, the computer and data processing service had 419 companies in it. Then we decided to also drill down a little bit more into the companies that had indicated in their actual returns that they were in the management other type of category. And there were 156 companies of that nature in the Northeast. And when we specifically analyzed them, we came up with 3 subgroups. One was about consultancy skills, people change, advice, learning, improvement, training, sector, and profession. The second one was similar. It was again about consultancy, but this time seemed to be more on the financial side. So it had investment, assets, account, fund, sector, performance, maybe. Obviously, we only have the stamp, so we have to guess the ending of the word. Plan, advise, and events. And then the third one was more on the web, creative sector, marketing, branding side of things, with strategy, improvements, web, advertise, hosting, consultancy, impact, and so on. So you can see how we can get some additional insights by applying our methodology, by collecting website data and analyzing that through a number of data science techniques to split the black box of other categories into 3 subcategories that we can make more sense of. And then we thought it would be useful to present the data. Back then, what we did was to basically plot the location of the services against the map and try to create some heat maps. They were just screenshots, so there was no potential way of interacting with them. And of course, that is a limitation because it makes it very difficult to, if you like, interact with the results and try to answer more specific questions or drill down to a more local level if there is such a need. So we thought, okay, how can we take this methodology forward, which is what we've been working through the project that was funded by the Office of National Statistics and finished a few months ago. So we thought, can we scale up the methodology in terms of the data that we use and the data sources that we utilize? Can we potentially run this longitudinally? And can we have a better way of interacting with the data so that users can actually access the findings or the results, if you like, and ask more specific questions? This is where the project actually became really big very quickly. Initially, we had only a few hundred of megabytes to deal with. But for the Office of National Statistics, we ended up with a project of about 170 gigabytes of data that had to be analyzed. And that was only, as you will see in a couple of slides' time, a very thin slice at the very top of the company listing in terms of the size. So, it's not an exercise that we can take lightly. And, if you just want to throw it to the entire country, yes, it can be done. But if you had some more specific research questions, it becomes far more feasible than just asking us to map everything. We also wanted to do it longitudinally. So we had to find a repository where we can access website data and go back in time somehow. We're fortunate enough, well, we knew that it existed, that's why we proposed to do it longitudinally, I suppose, that the Internet Archive has a service called the Wayback Machine, in which you can enter a URL. In this case, we have the Office of National Statistics website in the box. And you can see that there are a number of points across time since 1997 that captures of that website are available for downloading. And because we can do that, we can create, if you like, a time series of how that website looked over time. It did look very different to what it looks today. On the left-hand side, I have a version from 2000. On the right-hand side, I have a version from 2020. The web development, web design technologies and approaches to, if you like, the aesthetic side of the web have changed quite significantly. Which added an additional complexity to how we can consistently interpret the websites in an automatic way. For humans, it's quite easy to, if you like, see a website and pick on the right and important points. But for an algorithm, this becomes a far more complex task. So our role here was to basically take these websites, the underlying code, strip all the code out, keep the text, analyze the text, and come up with an answer as to what, for instance, the Office of National Statistics is all about. So as an input, we've used the FAME database. I mentioned earlier on that we picked the top slice because of our subscription at Newcastle University. We picked really large companies. And we started with a sample of 230K companies. The only thing we actually need for this exercise is the URL of the company and its address. Maybe just a postcode will suffice depending on the granularity that you want to go in. And then we started facing a number of challenges. So for instance, not all the companies were available in Wayback Machine to download them. Some companies were not there at all. Some of them were present, but there were gaps. If I go back a couple of slides, you'll see that there are some gaps. Say in 2007, there is only one capture around the summer period. But as time goes by, from 2010 onwards, as you can see, there are far more data captures, which makes it more feasible to do the analysis. There were also issues with the files that the Wayback Machine hosted. A lot of them were noise as far as this exercise is concerned. So we have to devise ways that we could, clean up what was not important and focus on what was important. When we decided also to scale up the number of web pages that we use for each one of the websites, in the cross-sectional analysis, as you have mentioned, that we only use the home pages. For the longitudinal one, we decided to use more than one page. We had an issue of selecting the other, say, 10 pages that we're going to use, because which 10 pages on a website are the most representative for what the company does. So the way they did was, again, to apply some data science algorithms to look at the available URLs we had and see how similar they were and try to pick a non-homogeneous set. So for instance, if you look at the examples URLs I have there, from 38 to 44, they are URLs that refer to financial results and reporting. So they're probably all very similar, while the first one is about our business and investment. So we can pick the URL number 5 and maybe URL number 38, but just ignore the rest because they will be too similar to give us any additional information. Then the big question was, how much data do we need? And to that degree, how long is a piece of string? We did some testing. We decided to set that number to 10. So we requested 10 pages per particular capture for a particular website. And then we put all that data together to create one moment in time with all the data that describe the moment in time. The more pages, of course, you want to include, the bigger the data set, the more complex the analysis, and the overall sort of project, scales up in terms of the effort and results you have to put in very, very quickly. And then, of course, once we've done all that trial and error, and we came up, if you like, with the way that we were going to approach the project, we had to do the downloading. Initially, we said we'll do only 5 years, from 2014 to 2019, for 5 pages per company, and only look at 3 regions. In my infinite wisdom, I decided to extend that. I don't regret it, actually, because it turned out to be a great choice, as you'll see later on in the analysis. But it did mean that going for 15 years for 10 pages per company and for all regions in the UK meant that the data set was going to be much bigger. I said earlier 170 gigabytes, actually it was 180 gigabytes, which required about 3 weeks to a month to download. So it does take a lot of time to set the machine to go and get the data. But the good news is, as once you do this, then it's done, and then you can ask the questions in different ways without having to re-download everything. So effectively, it's just a matter of doing this as a one-off, and then approaching the data through different analytical ways. We started with some 240,000 companies, but actually after we applied all the filtering and looking at what was available, we ended up with about 37,000 companies that we could potentially download and analyze. About 1% of all the companies across regions was not actually available, so we had to remove them from the list. And then we move on to the analytical stage, where we exported the data. We first had to combine it by regions. Part of that rationale was because we found that for individual regions, we didn't have enough data to do a longitudinal analysis. The algorithm that we use required to have a critical mass of data before the analysis can be undertaken. So one way of addressing that issue was to combine the regions so that a bigger data set per region was available and the algorithm would work more reliably. We applied a number of standard data science techniques involving clearing noise and terms that do not contribute to the meaning or interpretation of potential findings. So for instance, we remove all terms that had 1 or 2 characters. We applied some stop words, which are very popular terms that do not contribute, again, to meaning, like words like they or about or which or where. And then we've also extended the analytical tools that we had by creating what we call the dynamic phrases and the dynamic stop words. Now, if you do think of any website, there is typically some sort of navigation menu at the top, which is also replicated at the bottom. This is repeated across pages. So if you think about what you want to find, it's typically situated at the middle of the page. So we had to devise ways where we can reliably remove those top and bottom parts of the page, the header and the footer. And the way we did it was basically to see how many of these terms were repeated so many times and try to come up with a consistent way of removing the menus. We've applied language detection. Of course, we only wanted to analyze pages in English. Strictly speaking, that step would have probably been better placed at the beginning of the exercise, but as it took a considerable amount of time to get to this stage, we just applied it towards the end. And then finally, we applied imputation, which was a technique to fill the gaps. So for instance, if you had, as you have said, that we were doing the data collection on a quarterly basis. So if you had a data point in quarter 1 and a data point in quarter 3, but you missed the quarter 2 point, we basically copy them so that we had the continuous data stream for each of the companies. That resulted in what we call the process data set that was ready for the analysis, and the analysis could be cross-sectional or longitudinal. I'll give you some examples as to some of the findings or some of the results we got after applying both cross-sectional and longitudinal analysis. So I won't bore you with the details as to how we did the analysis, but we basically applied a technique that does not require any input. We basically throw the data to it. It doesn't have any assumptions. It doesn't require any information about the underlying structure. It builds this up as it goes along. And in our case, these are some examples of classes we've generated. So for Scotland and the north of England, the reason we have them together, as I mentioned before, is because we needed critical mass of data. Just to give you a sense of how we've combined the regions, we took a horizontal mapping approach. So the southwest and the southeast became one region. The Scotland and the north of east became another region, and northwest and Yorkshire and the Humber became another region. So we basically taken horizontal layers of the UK, trying to build up this the size of the data sets. So for the clustering in the Scotland and the north of England, we had clusters like finance and credit, and some indicative keywords were credit, finance, and payment. And we also had the logistic clusters, that was the service, logistics, container, and transport keywords. The keywords that you'll expect to get for these clusters do not have to be the same if you come up with, say, a logistical cluster in another region. So a good example of that is the education cluster we have in Wales and Midlands and London. As you can see, there are some common keywords like student, but they are not necessarily the exact same keywords between the two clusters. And then when it came to the longitudinal analysis, we basically mapped those clusters that we generated for each of the quarters across time. And we obtained graphs like the one we have in the slide. And as you can see, for this particular finance and credit cluster, there is a rising trend in terms of the number of companies that belong to that particular cluster. So this is not, if you like, a representative cluster in terms of maybe turnover or number of employees. This is just the number of companies. If we wanted to extend that and add additional sources, then potentially we could have more information as to the underlying size of the cluster with different matrices being applied. And then finally, when we came to the visualization and interacted with the results, we've created an interactive tool that is available at ebusiness.ncl.ac.uk. If you click on projects from the menu and then the Office of National Statistics project, you'll see that the tool is available. What effectively the tool does is give you a number of different criteria, filtering criteria that you can apply. So for instance, you can say, I want only to see the northern region, or I want to see London, and then see the clusters at a particular moment in time, but also run some sort of semi-animation type of visualizations where you can see clusters changing over time. So that's in a nutshell the methodology. And the big question, as I mentioned at the beginning, is how can we potentially apply it to like the one we have to practical situations where we can inform policy in different ways than the existing methodologies permit. So that's from me for this part of the event. I'll hand over the microphone, so to speak, to Mark and Martin.
Thanks, Savas. If you stop sharing your screen, Savas, I'll share my presentation. There we go. Let me know when that's come up. Can we see that now?
You want to put it on slideshow, Mark?
Oh, that's right. Keep forgetting that step. There we go. Okay, so thanks, Savas, for that presentation. I think it's particularly relevant that we look at new ways to understand what's going on in the economy now more than ever, particularly as things are changing quite rapidly, and particularly as you know, as an organisation that has quite a significant policy role in the area, that we can continue to look at new ways to analyse, new ways to understand in a sort of more timely way than maybe some of the traditional sources of economic data that we might rely on. So that was particularly the interest in us being involved in this seminar, to explore the methodology, as Savas says, in terms of its usefulness, its adaptability, and where we can take it from here. And we have explored a number of different ways that we can start to apply that, which I think Martin, my colleague, will touch on shortly. So myself and Martin Wood, who's also in the Zoom call, but I'm not sure whether you'd be able to see him at the minute. We work for the North Tyne Combined Authority, relatively new organisation in the area with responsibility for a number of different agendas, but particularly economic growth, working with the three local authorities north of the Tyne, Northumberland, North Tyneside, and Newcastle. I thought it was probably worth us just responding in a short way to Savas's presentation and the issues it raises, and tell people a little bit about us for those who don't know. So we are a mayoral combined authority. We have a mayor called Jamie Driscoll who was elected just over a year ago. As an organisation, our primary purpose is to deliver against the devolution deal that was agreed with government, predominantly focused on economic development. But the diagram on the right hand side shows some of the other areas and agendas that we have a role in, including inclusive economic growth and regeneration, increasingly low carbon and digital economy, skills and inclusion, with all of that focused towards jobs, productivity and GVA growth ultimately. And increasingly now in the context of COVID, post-COVID economic recovery and economic resilience in the face of that as well. Broadly speaking, we're a mix of powers and funding, with 20 million a year of discretionary investment from government over 30 years. And we are largely policy and investment focused as an organisation. We don't deliver directly a significant amount of interventions, but instead procure, invest in, and convene a number of different partners to work with us to do that. And principally, good policy and investment is underpinned by good intelligence, I think, is the starting point for us here, and particularly when it comes to new approaches to data and insight, they're particularly important to us for a number of different reasons. And the first one is making sure that we start from the right place of understanding in everything that we do, whether that's planning out approaches to sectoral growth around low carbon or digital economy, for example, or whether it's some of the more social and inclusion oriented interventions that we might support. And I suppose a critical issue in doing that for us, particularly now at the time when things are changing so rapidly, is that a lot of the mainstream data that we rely on is incredibly laggy, for want of a better term. Some of the data sets that we rely on from a national statistics point of view can have a lag of up to 2 years on them, which clearly, if published tomorrow, are not going to tell you an awful lot about the impact of COVID, for example, on our economy, and that economic change that we're undergoing is now quite significant. But approaches like the one that Savas has outlined for us is particularly important in identifying areas of growth and picking up some of the trends that Savas has highlighted are identifiable through things like using the wayback machine in the case of his analysis. But it's also about a more real-time ability to identify and mitigate some of the sectoral vulnerabilities through COVID, and clearly to be able to understand that and do that requires a level of dynamism within our data that we don't have as a general rule. Some of the new sources of data, particularly from Google, footfall data, etc., have been incredibly useful in understanding the impact of COVID on city centres, but it's not yet mainstreamed, I don't think, in terms of the use of big data within our area of work. And to do all of this, data and insight is critical, and that not being out of date as soon as it's published would be incredibly useful. So Martin's going to take us through the next couple of slides, and then we'll hand back to Holly.
Okay, as I guess many of the people on this call attending this seminar will know, it's quite difficult to get useful sectoral data. And most people who've tried to use the standard industrial classification categories on the ONS websites or through NOMIS will know that people will say, well, it doesn't really quite capture what we want it to capture, or it doesn't really make sense. Indeed, a review of that industrial classification is well overdue. It's been 13 years since they've revised the categories, and obviously a lot has changed in those 13 years. So it's something of the existing data that we have on industrial categories is something of a blunt tool. It's outdated. There's also a lack of detail at appropriate geography, and what I mean by that is when you try and dig down under the by geography, what you find is that the ONS has to combine its categories in order for it to provide any reliable data. So it's it's difficult to use because of that, and it fails sometimes to capture complex business structures. So particularly where there are group structures and multiple categories, it's difficult. So some businesses will register under multiple different categories. Some will register somewhat annoyingly on catch all categories such as management, other, or something of that nature, which doesn't really tell you what it is that they're engaged in. So what we do know is that there's been a rapid change in the nature of business activities, and that's particularly, I guess it's almost tautological to say it's in innovation. So in those, what we call innovative growth sectors, and especially in the digital sector, there's been a kind of rapid change in the nature of work. And so what you find is that the rather dated standard industrial classification does not capture the complexity of the situation that we're in now. And when we're in the business of trying to identify emerging clusters, and in the context of COVID, vulnerable sectors too, those sectors that have been adversely affected. And so, a technique that enables us to have more timely data, particularly on the formation and dissolution of businesses, and kind of preferably mapped in the way in which Savas has indicated, is of great value to us. So I think we start our response by saying we really do welcome efforts to develop more sophisticated approaches to classifying and tracking different sectors. So if you could move on to the next slide. So the question is big data part of the solution? Well, we think it has to be. Clearly, there's this wealth of data floating around on the internet, and surely there's a way of trying to use that. But we appreciate that our ability to do something with that data is at an early stage, but we certainly welcome the development work that Savas has engaged in. One of the problems with big data is there's a lot of data but very little intelligence, and any actionable insight that can be created from the rigorous analysis of that data is what's needed. So as a combined authority, we'd be very keen for any additional intelligence on our sectors, and we're keen to work with Savas to explore that. We want to make sense of the data that's available, and we'd like to explore ways in which those new sources of data can be combined with and integrated with existing sources, such as the company's house records. And I know that Savas has done that to some degree. Obviously, there's a lot of missing data. I mean, it's remarkable the number of companies registered with Companies House for whom there isn't a record of a URL. No doubt that will change, but it's surprising that that's the case. And any system that can be developed to automatically trawl and analyze those websites and do so by identifying keywords is valuable. I think I think anything that adds to a greater granularity of data is particularly welcome. So anything that provides a robust analysis of those changes over time and across geographies is to be welcome, and we look forward to exploring those further with Savas.
Okay, thanks, Martin. I'll stop sharing my screen there. Has anyone got any questions on that before we hand back to Holly to take us into the next stage of the session? I think it's fair to say that Savas is particularly keen to get the insight of the people on the webinar in terms of how the how the methodology can be used. Clearly, we've given a reasonably straightforward response to Savas's work, in that yes, more insight is great. Yes, big data is potentially part of the solution, but clearly we only have experience of one part of this agenda, which is very technical and very complex, and we're at the policy end of doing something with the data and insight rather than the technical end of how you actually get there. So I think any views that people have got on that would be welcome.
So we're just going to move into a short question and answer session now. If anyone has any questions, if you could please enter them into the chat function and I can read them out to our speakers. So the first question is, has your analysis been able to identify any emerging trends, e.g. sectors growing / declining?
Well, that's a great question, and unfortunately, I don't have a specific answer to it for two reasons. The first one was because we're primarily interested in the methodology. We weren't starting with a specific research question, so we weren't looking at any specific trends as such. And secondly, because we've captured all the regions in a way that makes sense, primarily from the data perspective, trying to interpret that in a way that kind of makes sense, maybe a dangerous way of going about. So, for instance, I gave you an example of the finance sector would seem to be from longitudinal to be on the growing trend. However, that's only including the number of companies in the cluster and not maybe the size of the companies, or there may be more companies, but smaller companies. So it may not be actually growing, but actually be in decline as far as revenue or headcount is concerned. In order to make this kind of, come up with this kind of answers, you need to have very specific research questions. So for instance, if you were to ask me, has the finance sector in this particular region been on the grow, or is it declining? Then we can go and focus our attention to it. We can add additional information like Mark and Martin mentioned from other sources like Companies House. And then we have a more holistic way of answering the question. At the moment, what we've done is just basically try to look at all the potential problems, challenges, but also the opportunities, if you like, across the data collection, storing, processing, analyzing, and visualizing, so that we have some sort of methodology that can take you from A to Z. Which bits of that methodology you need to answer these questions? It depends on the question. So what we're looking is this kind of more specific questions that we can apply the methodology and come up with the answers. And then we can say, okay, how does this answer look like compared to answers that we already have? And does it stack up? Does I agree? Is it aligned? Or is it completely different? And why is that?
We have another question here. So a really great project. How did you decide on defining geography? Company websites can be faceless, locationless, and company house registrations can be head office / account based and not necessarily where the business is located. A real issue for small companies and franchises.
Yes, and it has been one of the things that we had to trial a little bit different approaches. So especially because in this particular sample, we're dealing with big companies. As you can imagine, they have a number of subsidiaries. I only found that halfway through the methodology development, so I had to take a few steps back, which was quite painful, and do something about it. So a simple solution we came up to move forward was to pick the company that among all the companies that shared a common URL, and just pick the first one that appear in the list, i.e. the biggest one. So effectively, we remove any duplicates of other companies that had the same URL. And then in terms of positioning somewhere on the map, we basically use the headquarters of the group company and use the postcode to add that pin on the map. Websites, of course, do not have to be hosted at the same place that the company is. So just looking, if you like, the more technical side won't actually give you any advantage.
There is a question. A question for Mark and Martin. Have you seen the recent Creative Radar report from the Creative Industries Policy and Evidence Centres? This uses similar web scrap data together with survey data to show microclusters clusters geographically. We are trying to adopt this method in the Northeast with a view to informing cultural and creative industry policy in the North of Tyne Combined Authority and the LEP.
Yeah. Okay. No, I haven't. Is the start point? So I'd be interested if you could maybe pop me either pop that to Holly and she can forward it on to me, or send it to me directly. But I think this approach particularly is useful in a number of different ways, and as I think your question alludes to, not necessarily just the quantitative identification of how big a sector is or how many companies there are, but probably in a more qualitative way how individual companies or organizations within a sector describe themselves. And this is a challenge that that we face, probably from a point of view of all of the sectors that we work in or work with that are particularly broad in terms of their scope. So creative industries, particularly broad in terms of the the edges of that, which are quite blurry at the best of times, and particularly the digital sector as well, where it's quite often to pull together a singular narrative around what we mean in terms of the digital sector. So I think that Creative Radar report, I would assume, has attempted to add some richness based on how organizations describe themselves to what can be a fairly two-dimensional analysis if we just purely rely on economic data. Hopefully that.
Holly, and if I may add one point to Jonathan's question and to Mark's answer, I really like actually the Creative Radar label, because effectively that's why I was thinking of using this, not just for the creative industry sector, but just basically creating an economic clustering radar. Jonathan probably remembers we did something similar for the Creative Fuse project when we applied this methodology to the creative sector. And coming back to the point I mentioned earlier on in terms of comparing the results with other sectors, with other techniques, we also had a survey of creative companies in the Northeast, and we look at what they reported as doing, and some of the findings from both approaches seem to be aligned. So I think this idea of complementing, the intelligence we have and trying to see things more holistically and not relying on any single particular method of giving us an answer is a better bet for policy and for the longer term strategy that we have.
Thank you. Oh, one more question. Are there any plans to combine the local authority open data sets, such as those held for non-domestic rates, the LLPGCT, and combining them with company house data?
I think one of the areas that we're keen to explore with Savas is what data sets are available, either at a local authority level or because of the nature of the combined authority and the fact that we're relatively new, we're in a fortunate position in some senses that we don't have a massive data infrastructure that that we need to maintain, but it also means that we can be reliant on other sources of data that aren't maintained and owned by us. But I think this features that's what it leads into a broader agenda in terms of the combined authority, which is how do we support the digital sector and organisations to use digital and technology and data more effectively in a broader sense. So one of the areas that we've recently announced an investment in is the National Innovation Centre for Data, and how we can expand their ability to work with locally based SMEs to better use data, either to improve productivity or to innovate. A part of that same skill set that works for small to medium-sized enterprises in terms of data science is also clearly something that the public sector can benefit from in terms of better evidence-based policy making. So we are actually looking at how we build on that partnership with the National Innovation Centre for Data to bring in and their expertise in a number of different ways, using local authority data sets to to do something similar to what the West Midlands have actually done in terms of an Office for Data Analytics type model of bringing in high level data science skills into the realm of public sector to inform evidence-based decision making as well. But nothing agreed solidly in terms of the data access, but certainly something that's on our to-do list. Yeah.